So we're looking at the second method for solving problem 20 of the MIT integration B, qualifying exam 2016. The definite integral from x equals to 0 to x tending to infinity of 1 over 2 plus cos x. We've already looked at a problem where we use the substitution of the hyperbolic cotangent to really simplify the denominator, but we're going to look at another way of looking at it. So this is our problem, right? Integration from x equals to 0 to x tending to infinity of 1 over 2 plus hyperbolic cosine of x. So hyperbolic cosine cos x is the same as e to the power x plus e to the power negative x over 2, right? Now, which means our problem is 0 to infinity of 2 plus e to the power x plus e to the power negative x over 2, which is the same as 0 to x tending to infinity of 1 over 4 plus e to the power x plus e to the power negative x over 2. And that 2 goes up, and so we have 0 to x tending to infinity of 2 over 4 plus e to the power x plus e to the power negative x. Now, one thing we could do is, we already have our problem as follows. Right? I could also rewrite this as 4 plus e to the power x plus 1 over e to the power x dx, so that I could summarize it in such a way that this is 4 e to the power x e to the power 2x plus 1, like that. Now, if we have our problem as shown here, e to the power x plus 2 squared is equals to e to the power 2x plus 4 power 2x to the power x plus 1 plus 4, rather. And so this part here is the same as, in other words, for e to the power x plus e to the power 2x is the same as e to the power x plus 2 squared minus 4, right? So I can pull this part here and just plug that in there. So let me box that, right? So we have integral from 0 to infinity, 0 to x tending to infinity of e to the power 2x of ex plus 2 squared minus 4 plus 1 dx. So now we have our problem that is obviously from 0 to x tending to infinity of e to the x plus 2 squared minus 3, right? So which could also be expressed as e to the x plus 2 squared minus square root of 3 squared, right? And using the difference of two squares, this becomes ex plus 2 plus root 3 e to the x plus 2 minus root 3, right? So let's use partial fractions there. This is 2 to the x, 1 over e to the x plus 2 minus root 3. And I think we want to go with the minus approach. So minus 1 over e to the x plus 2 plus root 3. So that when you combine it, we have e to the power x plus 2 plus root 3 minus e to the x minus, and so as the denominator we would have to put here 2 root 3, right? And these 2's would cancel. And eventually now you have 0 to infinity, and we have ex, we have 1 over root 3 out, over e to the x plus 2 minus root 3 minus e to the x plus 2 plus root 3. Okay, so this becomes, as you can see, we have natural log of ex plus 2 root 3 minus natural log of e to the x plus 2 plus root 3, 0 to infinity. Okay. I think the best way here to proceed is to express this in a fraction, log of e to the x plus okay. And as we can see, so let's go ahead and say this is the same as limit as x tends to infinity of the natural log of e to the x plus 2 minus root 3 over ex plus 2 plus root 3, and then obviously we have 1 over root 3 here, minus limit as x tends to 0 of natural log of e to the x plus 2 minus root 3 over e to the x plus 2 plus 3, 1 over root 3 there. So as x tends to infinity, what is easy to see is that this tends to the entire this tends to 1 because they converge at pretty much they diverge at pretty much the same rate. But to make it a little bit clear, so you're left with log of 1 plus 2 minus root 3 over ex over 1 plus 2 plus over e to the x, right? And we're looking at limit as x tends to infinity. And you see this part tends to 0, and essentially this tends to log of 1, which is 0. So let me square that out. So when that tends to 0, what we see is that this tends to 1, this tends to 1, so we have 3 minus root 3, and essentially we just have negative 1 over root 3 log of 3 minus root 3 over 3 plus root 3. Okay, which is 1 over root 3 log of 3 plus 3 root 3 over 3 minus, because we've just inverted the fraction in there, and this is 1 over root 3 log of so we have 9 plus 2, actually this is 6 6 root 3 plus 3 over 9 minus 3, which is equals to 1 over root 3 log of 9 plus 3, we have 12, plus 6 root 3 over 9 minus 3 is 6, so 1, 2, and so we have 1 over root 3 natural log of 2 plus 3 is over 1. Okay, so in other words, our integral from x equals to 0 to x tending infinity of 1 over 2 plus cos x is equals to 1 over root 3 natural logarithm of 2 plus root 3, and that there is our answer.